there's something mysterious about Old Harry, a solitary chalk pillar standing alone away from the Dorset cliffs. Old Harry stands at the tip of a chalk headland that juts out from the bays of Swanage and Studland. He did have a partner, Old Harry's wife. But she fell victim to the waves 100 years ago in the storms of 1896. All that's left of her is an eroded, rocky stump. But to solve Old Harry's mystery, to discover where he came from, and to predict how he might meet his end, we need to look for clues that will take us far back in time. To do this, we need to look closer into the nature of the very rocks themselves. Magnified 10,000 times, we find the fossil remains of microscopic organisms called coccoliths. These single-celled organisms swam in a warm prehistoric sea 65 million years ago. As they grew, they built their shells from chalk. When they died, their remains sank to the seabed. Over thousands of years, millions of their tiny bodies formed a gigantic marine cemetery. It's these coccoliths that formed the chalk rock that now makes up Old Harry. So Old Harry at one time must have lain underwater. But how did the chalk that formed underwater become Old Harry? "65 million years ago, when these organisms swam the seas, the landmass that now forms Britain was very different. What we now call southern England lay beneath a tropical sea. In later years, during the Great Ice Age, sea levels began to fall, and the seabed containing the chalk rock was exposed. The chalk cliffs that now rise above the sea are made up of layers of dead organisms compressed over millions of years to form rock. Looking at the face of Old Harry, we can see different layers etched out by different rocks embedded in the chalk. This one is flint, and further evidence that this whole area was once a seabed. These hard nuggets of flint are formed from the remains of sponges that lived in the same seas as the coccoliths that formed the chalk. When they formed, the layers of flint and chalk would have been horizontal, but enormous tectonic forces folded the rock. Today, the layers rise up from the sea and form the distinctive patterns we see in the rocks. If we look down on this area of the Dorset coast today, we can see that Old Harry lies at the end of a headland that juts out from two bays. Here lies a second mystery. We know that Old Harry is mostly made up of chalk. Soaked by the sea, the chalk becomes soft and crumbles easily. So why does he jut out into the sea while the land either side has been washed away? The answer lies in the geology of the area. If we put a geological map over an Ordnance Survey map, the reason for this becomes clear. A geological map shows the rock types that make up an area. We can now clearly see how the chalk seam runs like a ribbon through two beds of clay. When the coast first formed, it would have been straighter. But over time, the softer clays either side of the harder chalk have been more easily eroded by the power of the waves. But the waves can create as well as erode. The chalk headland absorbs some of the power of the advancing waves, causing the waves to bend and slow as they approach the bays. The waves that lap on Studland and Swanage bays in calmer water now deposit these sands to form the beaches that lie either side of the chalk headland. But in winter storms, the destructive waves return. For centuries, these waves have been eroding the chalk outcrop and gradually forming Old Harry. At one time, the chalk would have sloped gently into the sea, but over thousands of years, the waves have slowly carved into the rock to create the chalk cliffs. Beneath the chalk cliffs that make up Old Harry, we can see how this has happened. The waves undercut the chalk, forming hollows. These hollows at the bottom of the cliffs get deeper and deeper until the cliff face becomes unstable and eventually collapses. We can now see how the chalk was formed beneath an ancient sea, was pushed up by tectonic forces, and then eroded by the waves to form the cliffs of the headland that jut out from the bays. But this doesn't explain how Old Harry stands alone as a stack, separated from the cliffs. As we head along this coast towards Old Harry, we find clues in the cracks, caves and arches as to how he was finally formed. The most severe erosion occurs where the waves attack the cliffs at their weakest points, the cracks in the chalk. As the waves strike the cliff, pockets of air in the cracks are compressed by the force of the water. As the waves retreat, the air is released like a cork from a bottle. It is these tiny explosions that weaken the rocks. Eventually, the cliffs become so unstable that the inevitable happens and rockfalls occur. This is called hydraulic action. So, if we put these clues together, we can work out that 4,000 to 5,000 years ago, the cliffs containing Old Harry would have looked something like this, largely complete except for joints and cracks. Then cliff erosion, caused by the hydraulic action of the waves, would enlarge these faults into crevices. Eventually, these crevices were eroded into caves. Slowly, the sea carved ever deeper into the caves, quarrying through the headland to form natural arches of rock. Only a few hundred years ago, one of these arches collapsed, and Old Harry and Old Harry's wife were formed. Eventually, Old Harry's wife fell into the sea, leaving Old Harry to stand alone. But erosion is a continuous process. Once again, the sea works on this debris, dissolving the chalk into the water to provide a chalky meal for new, tiny single-cell organisms, descendants of the microscopic organisms that formed the chalk stack we call Old Harry.